It seems like you can't go a day without hearing about artificial intelligence, right? It's absolutely everywhere. But here's the thing. The technology is moving so fast, but the language we use to talk about it, that's changing even faster. And I am not even kidding. This actually happened. From our toothbrushes to our data centers, AI is just becoming part of the background of our lives. But to really get a handle on what's going on, you gotta speak the language. So that's what we're gonna do right now. We're gonna cut through the noise and demystify 7 of the most important AI terms you're gonna hear today. By the time we're done, you'll be able to follow the conversation and really understand what's driving the future. All right, let's get into it. First, we'll look at what AIs are starting to do on their own. Then we'll get into how they access knowledge. After that, we'll see how they're getting bigger and smarter. And finally, we'll peek into the future and see where all of this might be heading. Okay, first up, let's talk about one of the biggest shifts happening right now, the move from passive chatbots to AIs that can actually do things. This really comes down to 2 key ideas, the agent itself and the special kind of brain that powers it. You have probably heard the term AI agents popping up all over the place. The key word here is autonomy. See, a normal chatbot just waits for you to type something. An agentic AI, on the other hand, gets a goal, something like book me a flight to Paris, and then it figures out all the steps and actually does them on its own. So how does it do that? Well, it all comes down to this loop. An agent is constantly cycling through these 4 steps. It looks at its digital world. It thinks about what it should do next. It takes an action, and then it looks at what happened and uses that to decide its next move. It just keeps going, around and around, until the job is done. And that is the million-dollar question, isn't it? What does it actually mean for an AI to think or reason through a problem, to make a plan? Well, that brings us to our second term. So meet the LRM, or Large Reasoning Model. You can think of this as a specialist brain that's really good at problem solving. A standard large language model, an LLM, is amazing at predicting the next word in a sentence. But an LRM is specifically trained to take a complex goal and break it down into a logical, step-by-step plan. You've probably seen this before, right? When you ask a chatbot a tough question and it pauses, showing a little message like, thinking. Well, a lot of the time, that's an LLM at work. It's basically talking to itself, generating an internal chain of thought to map out the whole problem before it gives you that final, thought-out answer. Okay, so an agent with a reasoning brain is pretty powerful, but what happens when you give that brain a library card to access, well, pretty much all the information in the world? Let's look at how AIs are getting their own massive libraries. Now, this is a total game changer. A vector database doesn't store things like text or images as they are. Instead, it converts them into a long string of numbers, a vector. And that string of numbers isn't random. It's like a mathematical fingerprint that represents the meaning and the context of the original data. And here's where it gets really cool. Because everything is stored by meaning, you can search for things in a totally new way. You could search for a picture of a mountain vista, and it won't just find other pictures tagged with mountain. It'll find things that are mathematically similar, so maybe articles about hiking, or even a piece of music that feels majestic. You're searching by concept, by the actual vibe. So how do we plug our AI brain into this amazing new library? Well, that's where RAG comes in. RAG, or Retrieval Augmented Generation, is basically the bridge. It's a system that, before the AI even tries to answer your question, goes and finds the most relevant information from that vector database and gives it to the model as context. The best way to think about it is like an open book test. Let's say you ask a chatbot about your company's vacation policy. Instead of just guessing based on its general knowledge, RAG instantly dives into the employee handbook, pulls out the exact relevant paragraph, and hands it to the AI. That way, the AI isn't just making something up. It's giving you a perfect, factual answer based on the real document. All right, so we've got these autonomous agents. They have reasoning brains, and they have access to huge libraries of information. The next big challenge is, how do we make them bigger, faster, and more connected to the real world? That's where our next couple of terms come into play. So, for a long time, AI models were what we call monolithic, just one gigantic brain trying to be an expert on everything. The newer, smarter approach is called mixture of experts, or MOE. Just imagine a team of specialists. One is a genius at language, one's a coding whiz, another's a math expert. When your request comes in, the system is smart enough to only activate the experts it actually needs, which makes the whole thing way, way more efficient. Now, for an AI to be really useful, it needs to connect to everything else. Your calendar, your email, your company's databases. Building a custom connection for every single tool is a nightmare. So the idea behind the Model Context Protocol, or MCP, is to create a universal adapter. It's like a USB port for AI, a standard plug that lets any model easily connect to any outside system. We've covered the technology that's here today and what's just around the corner. But for our last term, let's zoom all the way out and look at the ultimate theoretical endgame for a lot of people working in AI. First, we need to separate two really important ideas. You've probably heard of AGI, right? Artificial General Intelligence. That's the idea of an AI that could do any mental task a human can. But that's just a stepping stone to something else entirely. ASI, or Artificial Superintelligence. That's a whole different level. An ASI wouldn't just be as smart as the smartest person you know. It would be more intelligent than every single human on Earth combined. Right now, this is purely theoretical, it's sci-fi stuff. But the core idea is an intelligence so massive, we can't really even wrap our heads around it. And this phrase right here, this is the part that gives everyone pause. Recursive self-improvement. That means an AI could literally redesign and upgrade itself. It could make itself smarter, which would let it make itself even smarter, faster. It's an accelerating, potentially endless cycle that we would have no way to predict or control. The stakes here are just staggering. An intelligence like this could, in theory, solve everything. Climate change, disease, you name it. But it could also create existential risks on a scale we can't even begin to imagine. It is the ultimate double-edged sword. So let's quickly recap our journey. We started with Agentic AI, those systems that can act on their own, powered by large reasoning models that help them think. We learned how they get their facts straight from vector databases using a technique called RAG. Then we saw how they're being built smarter with a mixture of experts and connected to the world with a Model Context Protocol, all while the entire field is aiming for the mind-bending, theoretical future of artificial superintelligence. So there you have it. You are now armed with the essential vocabulary to understand this next huge wave of AI innovation. The question really isn't what these terms mean anymore. It's what are we all going to do with the incredibly powerful technologies they represent? So what will you be watching for next?